Anderson Award. And okay, the meeting's being recorded. Great, thank you so much. So yeah, I'm very, very excited to share this with you. This research was also very groundbreaking. Mobjack Bay, the place where we did our research in the Lower Chesapeake Bay, this was ground zero, and this research was featured in Oceanographic. It was in the Bay Journal, also the New York Times. This was pretty major that we got this media attention for what's happening in the Bay. Also, the Chesapeake Bay Magazine. So just for some context with myself, I've been studying ospreys for about 9 years now, from the West Coast, California, all the way to the East Coast. But I grew up in Hawaii and I come from a fishing family. Here's my dad here with this giant yellowfin tuna, and we practice, sustainable ways with line. We don't use any nets. And here I'm carrying some fish from the West Coast. So fishing for me is, I'm like an osprey, I need fish. And when I saw ospreys in California for the first time, that was it. I just fell in love and I knew I had to work with them. But the reason why I really fell in love with ospreys is because, before we had technology such as fish finders, what did we use in our environment to help us locate fish? We used birds. And ospreys are just highly visible. They will bring the fish out of the water and they will tell you a lot of information. Okay, so my research at William and Mary is how food supplementation increases reproductive performance of ospreys in Lower Chesapeake Bay. In this presentation, I'll go over the protocol, which includes the introduction, methods, results, and the discussion. And let's have some time for questions and answers. We put a camera on a nest, and there was a storm, and the camera changed the view from the nest to the outside. So here you can see a picture of my advisor. Here's me. Here's a research vessel. And I promise I'm not reading a book here. I'm just furiously taking notes from my advisor. He's just going on and on and on, so I kind of have to be very speedy with the pen and get everything he's saying. That's Dr. Brian Watts with the Center for Conservation Biology. Okay, so more introduction about fisheries. This is an illustration from the Food and Agricultural Organization depicting where the trend is going with fisheries. On the x-axis, we have years. On the y-axis, we have percentage. Here in orange, we have the fish stocks that are overfished and unsustainable, and that is growing. Here in this teal color are the fish stocks that are fished at maximum sustainable yield, and this is shrinking over time. Here, under this white line, represents the fish stocks that are underfished, and this is approaching zero. So with this global concern with the state of our fisheries, there's been a paradigm shift from single species maximum sustainable yield to a management style that considers trophic interactions, and that is ecosystem-based fisheries management. And this is a holistic approach that considers your trophic interactions and aims to promote the health and resilience of the entire ecosystem. And embedded in this management style are ecological reference points. And these are your top predators, which can enable management to make informed decisions to develop harvest targets and assess the role of forage fish here in the upper trophic levels. Bird populations may serve as an early warning system for changes in fish populations that have ecosystem implications. Okay, this is menhaden. Some of you may know it as bunker. It is a type of herring with a very high lipid content. And because of this high lipid content, it's highly sought after. They're a surface schooling fish in the thousands. So People consider this, not the best fish to eat, but it's used for so many things. Now, before 1950, there were about 20 industrial companies north of Chesapeake Bay fishing for menhaden. But after 1950, only one industrial company remains that is omega protein. And most of the companies failed because of fish scarcity. So the problem with omega protein and with our technology is that we've become so efficient in how we harvest fish. In fact, omega protein has about 7 or 8 of these ships. They also have spotter planes. So the spotter planes locate these schools of fish. The ships surround them. They use these purse seines. They surround them and they literally vacuum all of this fish. And it is big, big business. Omega Protein is part of a conglomerate called Cook Industries. They're worth about $6 billion or so. But the fish, their derivatives are used for fish oil, fertilizer, bait, even pet food. Now, the problem is this: Chesapeake Bay serves as a critical nursing ground for menhaden. They provide a major ecological service. They're a forage fish, a food base for our most iconic species such as striped bass, loons, whales, bald eagles, of course, ospreys. And we can't forget about our fishers and ecotourism. So this is tragedy of the commons. According to the Atlantic States Marine Fisheries Commission, this is the commission that governs the fisheries. Localized depletion is defined as this: it is a reduction in the menhaden population density below the level of abundance that is sufficient to maintain its basic ecological, economic, and social cultural functions. And now we are seeing evidence of this. All right, so why ospreys? So here at the Center for Conservation Biology, we have about 4 generations of graduate students studying the relationship between osprey and menhaden, and we have determined that osprey reproductive success is inextricably linked to menhaden. Ospreys are highly visible. You can see them catch the fish and bring it into the air so that everyone can see. They're obligate piscivores, meaning that they depend on fish 99+% of the time. Ospreys are also the only bird of prey that are able to dive into the water completely and bring out their fish. So they're plunge divers. And plunge divers are more susceptible to the perturbations in the food supply compared to your pursuit divers such as cormorants or loons. Ospreys have been substantiated as ecotoxicological sentinel species. Everyone remembers DDT. But their use as ecological reference points or indicator species have not yet been fully explored. The objective of this study was to determine whether the osprey population within the Lower Chesapeake Bay was experiencing food limitation during the 2021 breeding season. I'm not going to try to be so sciencey here, but let's focus on this piece of information here, which is lacking in Chesapeake Bay. Surprisingly, we don't have the menhaden density per area in Chesapeake Bay. They're just not doing it. So because of this, we had to find a workaround, and a food manipulative experiment in the wild was required. Hence, the main research question: would ospreys experience higher rates of nest success and productivity if they received food supplementation? We hypothesized that ospreys experience food limitation due to the lack of fish availability, and we predicted that the treatment group, the group that received the food, had increased productivity and nest success. So productivity and nest success are the metrics that we really want to pay attention to. Okay, we're now in the methods. Here is a map of Chesapeake Bay in its entirety. all of these red dots represent osprey nests. To conduct this study, it would just be impractical to use the whole Chesapeake Bay. So we determined to use Mobjack Bay here in this white circle. And this historically has been the bellwether of the menhaden and osprey relationship, especially in the higher salinity zones where menhaden are supposedly abundant and available. All right, let's zoom in into that area, Mobjack Bay, which consists of the Ware, North, and East rivers, and also Davis Creek. The blue circles represents the nests that received the food supplementation. The red triangles represent the nests that were not given the food. We had a total of 31 nests. All right, treatment protocols were initiated once eggs hatched to 6 weeks. And menhaden were sourced from a local fishing supply company and was prepared and delivered via a telescopic delivery device. You can see this device here on the left. And this was handcrafted and engineered by my dad. So thank you very much, Dad. And we delivered about 3.4 fish every 3.5 days on average until the young reached that 6 weeks of age. And also, we inspected the nest via a mirror pole. But before I show you the mirror pole, we had to develop the skill of placing the fish very carefully because you don't want to, plop the fish over the nestlings. So here, the trail cameras that we did put on the nest shows us, careful placement of the fish. We wanted to go around the nest, not in the middle. And if you pay attention or look here to the right here, you can see a little nestling here with a little bobblehead. We really want to be careful of this. The fish are much bigger than the nestling. Okay, so here is this contraption. This is the mirror pole that my dad also handcrafted and engineered. We took a filmmaker out on the boat and he attached a GoPro to the mirror pole. Uh, these are actually rear view mirrors that we took and we converted it. You can see the nest here. And also look at the nest contents. We have 3 nestlings here. They're very well camouflaged. See that line behind their back? They look like sticks, but you have 3 here. You have the eldest, the middle, and the youngest. You can see asymmetrical growth. Usually the eldest nestling will outgrow much faster than the middle or the youngest. I know that there's some issue with the audio, but you could hear them calling out for mom, and you're gonna see mom circle overhead here as well. So yeah, this was really awesome to capture. Okay, so we also attached these trail cameras to the nest. This was an old duck blind, and it was used over and over by osprey pairs, and you can see how just massive this nest is. I mean, I could fit in there. Um, so osprey nestlings don't have these colors. We used markers to determine the age or the order of the nestlings. Red was for the eldest, blue was for the middle, and green for the youngest. And we attached about 11 of these trail cameras to nests. We wanted to know what type of fish they were bringing into the nest. And this is what we like seeing. We like seeing them bringing in striped bass. There's been a big striped bass issue in Chesapeake Bay. There's lots of drivers that's causing this, but we also believe it's because of the menhaden issue. And what's interesting is that now with our technology and software, I can use known lengths such as the talon here or the beak, in which I can get the biomass of the fish. I can get the length first of this fish, and then by using species-specific length mass equations, I can get that biomass from that fish. And hence, I can also convert that into their energy content. Okay, I went over this briefly earlier in the introduction, but if you watch your ospreys there, or if you get involved watching some ospreys, these are some things that you want to keep in mind. It is nest success. A nest is considered successful when a pair raise at least one young to the minimum acceptable age for ospreys. That's about 6 weeks of age. We define the number of fledglings as the number of young in the nest that reach the 80% first flight age criterion. That's 6 weeks for ospreys. And this is a major, major metric that we used for osprey success or measuring how they are doing. This is your productivity or your reproductive rate. And it's basically the number of fledglings per active nest. All right, the results. So for the food addition group, 13 of the 60 nests succeeded at 81%. Only 3 nests failed during the first 1.38 weeks, and the reproductive rate was 1.3 young per active nest. Now for the control group, unfortunately, only 5 of the 15 nests succeeded at 33%. 10 nests failed during the first 2 weeks, and the reproductive rate was 0.47 young per active nest. And I'll be going over the significance of this value in the discussion. All right, I wanted to show you some interesting figures here. This is this is just a contingency table showing the successful nests versus the failed nests. So on the x-axis, we have the treatment type. On the left side, we have the food addition group. On the right side, we have the control group. So the successfulness represented in blue and the failedness represented in red. And we did a chi-squared analysis to test if there were significant differences between the two experimental groups. Going back to answering the research question, was there a significant difference between the food addition group and the control group in terms of nest success? And according to our stats, this was highly significant. Another part of our research question was looking at the productivity rate, if there were any significant differences between the control group here in red to your left and our food addition group to our right. Now, these are just some fancy violin box plots, which we're using now in the science world. I love these box plots because they really show the data, the density of the data, where the data reside. For the control group, for the productivity rate, you can see that most of the nests were under this 0.5, heading towards 0. Whereas with the food addition group, most of the nests had your productivity at 1 fledgling per nest. And we ran a model on this, and yes, highly significant. So again, answering the research question for nest success and productivity, there is a significant difference that food limitation was the factor here. Okay, no, this is getting a little fancy, but I love stats. So we also wanted to know how many or how much added average fish biomass was needed in order for the Chesapeake Bay population to be sustainable. And that was about 63.4 grams that we added per day. And yes, that was significant. Okay, so here's some more fun information here. I know the stats can be a little bit confusing, but it is important. The trail cameras, here are some pictures of some fish that were delivered. Here we have menhaden. We have a double delivery here. This is what we like to see because menhaden are schooling surface fish. So this is great. This is what ospreys should be doing in Chesapeake Bay. We have gizzard shad. Look at the size of this gizzard shad. It's pretty big. So good job, Dad, bringing that into the nest. So here we quantified the percentage of the fish, identifiable fish that was brought to the nest. We had 39% being menhaden, 10% river herring, 5.8% croaker, 5.7 gizzard shad, and 5% spot. And this corroborates earlier work with the generations of grad students at the conservation biology and the link between the menhaden and osprey success. Okay, so now in the discussion, let's go back to that productivity rate, which is, so important, something that we look for in osprey populations. This is a study that was done by Dr. Rob Beauregard et al., and this was the recovery for osprey populations during the DDT era. On the x-axis, you have years all the way from 1964 to 2000. On the y-axis, you have your productivity rate. All these different squiggly lines, dots, and squares here, this just represents the different osprey populations from southern New England all the way to Long Island, New York. This red dot here indicates the reproductive rate that ospreys need to hit in order to be sustainable. And for that worldwide mark, that's 0.8. Here from the 60s to the early 70s, you can see these osprey populations, the productivity rate was approaching 0.5. Here is where you had these osprey population crashes. And this is the significance of that control group in Chesapeake Bay of 0.47. This is well below that 0.8 level and below those osprey population crashes during the DDT era. We've been continuing our surveys. We followed up in 2023 in Mobject Bay, and unfortunately, out of 83 active nests, only 3 young reached that minimum age, 6 weeks. We don't even know if they fledged or not. But that productivity rate is just abysmal. That's approaching 0. I've never seen so many, osprey death in my life. That was very, very depressing. So in Chesapeake Bay, there needs to be a higher reproductive rate. This is because of the age of return. When parents, ospreys, they winter in the south, and the age when they come back. It's a little later for Chesapeake Bay. So that productivity rate actually needs to be higher for Chesapeake Bay. And that's 1.15 young per active nest. For a food addition group, that productivity rate was right there near our target at 1.13. Right here at Chesapeake Bay, we have the world's largest population of ospreys. It is a stronghold. We have about 20,000 individuals coming to Chesapeake Bay. But, with this productivity rate, especially along this main stem, this has been very concerning. Here's a picture of a nestling that we took while we're visiting the nest or taking measurements. Going back to this figure, we wanted to know, especially like with fisheries, like how do we deliver this information to fisheries? And that deals with harvest policy. And what is the biomass threshold needed for ospreys to be successful? And that's about half a pound of fish per day per nest. All right, so we've concluded that ospreys are sensitive indicators of menhaden availability and that the productivity rate of 1.15 young per active nest in Chesapeake Bay, this needs to be met in order for the population to be sustainable. But sometimes when you visit a nest, as we did, you can see that there's some asymmetrical growth within the brood. Here on the left, you have your eldest nestling, red here. You can see this nice full crop and a great body condition. Whereas the middle nestling, there's no crop and just complete emaciation. Yeah, for this nest in particular, the one marked as green, the youngest, did not make it. So that is very sad. There are a lot of people and organizations that I wanted to thank to help this presentation or this study to be possible. My literature cited. Here's some pictures of me handling the nestlings. It was just, such an honor to work with them, um, to hold them and to see them. Yeah, unfortunately, this study gave me great joy and lots of sadness. I don't have audio for this, but yeah, the filmmaker does have a documentary out. Maybe one day I can share with you, invite me back for that documentary. A recent one has come out, so stay tuned.